Okay. Today's date is Sunday, the 26th of April, 2026. Again, it's Sunday, the 26th of April, 2026. Okay, what am I talking about today? So I'm gonna speak in a calm tone. So the background is the battlefield, the battlefield. And this is what I'm saying. So it's about litigation. Now, I'm not really into the legal aspects of things. I can get started into it. So litigation is a process of solving problems. Like it's not just suing people, it's not a suing process. Usually, it's really can solve problems. Like, solve the kind of suing of people, but litigation requires final litigation. Basically, I believe it's about solving problems in the legal framework, addressing the problem of status of real framework. Basically, it's a court order, and you get what the community gets. The community gets what it wants. So, OHA is distributing decentralized governance and localized governance for public community. OHA, O for Oscar, H for hamburger, A for alpha, is community and building. And we get the zones, zone one, zone two, zone three, zone four, etc. But I'm building for the UK system, so the zone mode applies. So I'm going to build it for the UK. So because the UK weather is different. So this video was going to be about um was gonna be more about, yes, NSIGII, end of November. S for Sarah, I for Indigo, G for Gold, I for India, I for India. Never a never a problem, and never the problem. You know, never the problem. It cannot make problem for you. You cannot. You just solve the problem for you. So it's again never a problem. So the never a problem deals with kind of financial litigation autonomously. So it's a part of the Trident SDK of NSIGII, never a weapon, which is basically is food. It's never food. It can be weapon. It cannot be weaponized against you, and never a toy, which is other software development kits, which is like uh for the uh for the AI system I'm building. So these are human rights software development kits that will give you food, water, and shelter. But in Sigi, never a problem. Deals with financial liquidation, asset solving, kind of financial part of it, because food, water, and shelter costs money. It costs money, and you know, if we can solve this problem mathematically via economical principles, I've got a software that can sue people autonomously via Le Palico, L for Lima, I for Indigo, P for Papa, O for B for Papa, so Le Palico or Palico.exe. Now, I'm expressing that let me keep talking here, that the software development is trilateral. So OHA is community systems. Or for Oscar, H for hamburger, if I have this community, there are three of us in a community. Three of us make up a community. Anyway, there's three of us is community. And that's the idea. Two of us is bilateral systems. So basically, we have a consensus system of three of us. We have a bilateral system, bilateral consensus. So we have a trilateral consensus of three systems, of three of us, of EG. Three of us make up a community, and you got a bilateral system, which is two parties, two decision makers, that make it up Igu, which is law, and I Indigo West umbrella, and a G Indigo Justice Indigo is one of us. Uh, uh, Primarily, I want to speak about how the suing system works. So the SIG is never a problem, and it's never the problem. So never the problem means it cannot sue you, it cannot sue you. But it's just like a software development kit. So it has bindings, drivers, it has extensions, it has plugins, it has services, and these services are all created via all the protocol. And No, the goal is to use this. Oh no. Yeah, basically, it's not a good. It's not a really good philosophy to keep designing poorly, Namdi. So you're gonna have that's a very poor architectural pattern. I said that. So you're gonna have binaries, which are all binaries. Binaries map the map to surfaces, and it's basically polyglottic systems that I'm building. So via kind of without civil involved. But the goal is to have a litigation occur and liquidate financial aspects of things. So it does the kind of economic principles of finance. So I don't know about economics very well, but it's a very big topic. To make sure that the algorithm is like encoded via the three hard coded parts of breath, life, and not having work optional. Having work optional. So you don't have to work to sue people. But you're gonna have a conversation pattern. So if I have completely never weapon, never a problem, the polyglot system, is gonna be beneficial to orchestrate services. So second things second. First things first, second things second. And that's a good. What's my pen? We all shed blood, sweat, and tears. Uh, so I'm gonna build a compound in UK, but I'm gonna build it like a plaza, like a level. It's gonna be like a plaza. It's gonna be basically, today so I restarted the compound building, and basically zone one, zone zero is gonna be in the center, which is basically the community within this community, and you're gonna have houses in the kind of around the community. That's the idea. You're gonna have a house around the community. The plaza, so you're gonna have the plaza in the center. You're gonna have the houses around the community. So that's gonna say yes. So you're gonna have the plaza, which is like a small community. We can do video gaming. So I don't know how to learn about because finance is gonna be a long way. I don't do finance. I don't do robotics. I want to build NSIGII not a weapon or NSIGII not a toy. I want to build not a toy, never a weapon. So it's a trial after educate. So so you can use namespaces to map to find out and polycode to polycode the to determine what package is what. So you're gonna use seeking never weapon, which basically is the food, water and shelter being delivered, by the delivery system. It's just not a weapon, never weapon. So it can't be weaponized against me or anybody else in the community for that matter. And you're gonna have NSIGII never weapon, never a toy, which is basically the robotic systems that operate in the real world to give you food, water, and shelter. Are you gonna have so NSIGII never a weapon is the food, water, and shelter being delivered, the payload to be delivered, which is the food, water, and shelter, or shelter. NSIGII never never a toy is literally a robotic system that give you the robotic system, the drones, the robots, the things that go out in the community to get the food. And it's again never a problem. There's a sewage system. It's like it's a human, and it's basically you can sue someone to get big money out, and it does it all autonomously. So it's you sue someone to get money out. So it's gone to 8 minutes now. Anything I've written down here? No. Yeah, the plaza. I'm trying to build a plaza. So the first step is to blueprint the plaza. The plaza is the community area. So everyone's allowed in the community. Obviously, everyone's allowed in the community. But it's basically 1,500. So basically, 1,500 acres of land is basically what I'm using to model this. I get to understand that, I'm trying to, I haven't got my ruler here or anything, but, if I'm set up properly, I'll start drawing. So after this video, I'll start drawing too. So that's what I'm saying to you. So I'm trying to do. Basically, in seeking never weapon, in seeking never a toy, and seeking no problem. Anything else I've to add to get this to a point of 10 minutes? No. Anything important I missed? No. Uh, Anything about litigation? Yes, litigation. How this works? So, oh yes, how this works. So, well, I didn't show you how it works. Yeah, let me show you how it works now. Uh, Here we got how it works. So we have how it works here. So we have the Muko boot sequence. This is just one a system of them of creative phases to run competition algorithms. So you're gonna have Muko calibration system. So you're gonna have the epsilon corruption rate. So this one video of it. So the epsilon corruption rate. So this is basically the nothingness corruption. So you don't gain or you lose, so you lost. So you're gonna have this article on dev.2, which is one key insight of it. Bloodhead. So this is epsilon contribution. Epsilon means nothing, but this is corruption model. So it's basically to deal with kind of a suing and corruption and kind of a economy. So basically, I want food, water, and shelter to be free. Food, water, and food, water, and shelter to be free, or housing to be free. So you have to pay for your housing. So this is what NSIGII never weapon does, never a problem does. It uses the epsilon corruption lattice and the tripod discriminant. So the epsilon control lattice and the Ligana framework. This is not an army of two. This is going to be better. So you're gonna be planet 76. You're gonna have basically I'm looking for the documentation for it. Where do I keep it? So I'm on dev.2 .com. Why use Obix? So basically, really, why use Obix? So this OB, this is really a React compliance system. Basically, you use React code to model system of but you have using namespace to do it. So basically, this is the article. So Sigi, when systems fail, prove it. When systems fail, prove it. Is this recording? Yes. When systems fails, prove it. Don't beg them. When systems fails, prove it. Don't beg them. The epsilon corruption says, and the end of please help me. There's a quiet humiliation baked in modern systems. You apply for housing, you follow every rule, you meet every requirement, and still the answer is no. Not lightly, not validly, just bureaucratically. You're not eligible. You're not a priority. Try again later. It's kind of at least no fingerprints, no crime, no proof. It's a straw original authenticity. Most people stop there. Nsigi doesn't. So this is not a problem. The shift from complaint to proof. Nsigi is never a weapon, never a toy, and never a problem. Reframes the human role in the system. Never a weapon. Humans are not spaces by the systems. Never a toy. Humans are not ignored and overlooked. Never a problem. She could never the problem, but never a problem, never a toy because you but this is referring to both it's bi-directional referring to basically a system of bilateralism, I could like to call it. So basically it's just two treated people to solve the problem. So you're gonna have never a problem. Humans are not to blame for system failure. Instead of asking what is happening now, you ask, can system logically justify its own decision? That's the dangerous question. Because sometimes it can't. The lattice. When systems expose themselves, the framework behind the shift is the epsilon lack of knowledge. A mathematical structure that compares. So basically, the epsilon structure compares uh, what the system claims, what it does, and whether those two are logically coexist. So it's bilateral consensus, basically law, governance, and law. It's bilateral. So it's basically two systems, system agreeing with itself. Because those things, I would think what challenge you. That's what makes us sue people. So I'm trying to develop APIs to build Ziggy never problem. This is the first SDK I'll build. So basically, if I can sue people autonomously, I can automate the process of suing people in legal context without quota, without all the obviously. If I can convert everything to quota, everything is saying to quota, and outline it as outline notional work, corruption is not always invisible. It's often existed as what's called an epsilon state. Hmm. As systems that appear fair on the surface, both produce consistent or fair outcomes. That's not backlog, that's structure. The breaking point, when system collapse, when civil collapse, when a fair system must obey one simple rule. If you qualify, this is a path to success. But in many real world systems, this option collapses, this order system. This I love this paper, guys. I love this paper. When I wrote this paper, when I wrote with AI, not the problem. When I wrote this paper, I was thinking about corruption. It's a case study. This paper was a case study. It was a case study. I wrote this paper. But this is an article of the paper. So, but in memory rural systems, essentially housing and care structures, the path doesn't exist. You meet all requirements and still can be rejected indefinitely. Mathematically, this is a country condition. Eligible true outcome equals false. And there's no valid exception condition according to the two. This is called a complement violation. Translation. This cannot prove it is fair. It is fair. So if this cannot prove it's fair, you have to develop the bindings for the protocol and to sue people. That breaks the loop. Corruption doesn't always deny you directly. Sometimes it traps you. You send before housing, social care, support systems back in housing. Some no resolution. So for every path you take, every way there is to go, and every shape of the path, there should be a solution. Should have reached something, and because there's no path even, that means there's corruption, So that's what Miko basically does. Because there's no path, there's corruption. So for every way there's a path, every shape to that path, every way you structure the path, every way you do it, every way you structure the way to that path, and every way and it's corruption, every way you can do, every way shape and form the problem takes the solution. Because that solution has a path, and that's what corruption is trying to stop. And this is what the Epsilon entrapment by Lubeck does. So defines no solution, no input, just movement. Entrapment by Lubeck. So entrapment is literally denial, delay, defend. So if you entrap someone into a system, you are telling them go back to the start. You don't qualify, you don't meet requirement. But they clearly do. They just don't know any better, So they're going by Lubeck. So entrapment by Lubeck. Got entrapment by probability, which means like you basically about odds. It's just the odds against you. So you cannot win. You cannot you get all this control from system. This is delay, deny, defend, which basically delay, deny, defer, which is the dimensional game theory model of the problem. But the problem is basically a case study. It's a case study I done in the real world, and it's called the epsilon contrast lattice. So NSIGII putting humans back in the loop. Transmitter, your lubrication. Receiver, the institution. Verify the independent truth layer. You know, so it's never there should be never a problem with figure and short term, and that's why litigation matters. It's a litigation system. It is to solve litigation for you. Oh, it's a beautiful day today. Um, feed, water, and shelter. So you can buy food. So you can have money in your bank account to buy food. You can be autonomously suing people, and if we develop this properly, it will sue a lot of people, and people will be mad at me. So you get this article here, and you save as uh, 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 it's your right to sue people. Just implement the API properly, MD. Food water. This is math. This is about math. This isn't about math, fun. The real point is going to survive. It's about survival. Housing system control, shelter, stability, access to food and water. When systems structurally fail, people don't get frustrated. They get displaced. Like I was homeless to the level of 20 Don't remember, don't forget what I did. So, I'm trying to automate the suing process of the litigation practices, but I'm trying to do it properly. So I'm going to corruption and model corruption as entrapments. So you can find out proven fairness, proven equitability, in the system to make things more equitable for me. Um, NSIGII reframes access to note as something that was preferable, not initially consumed. And when the proof fails, legal structures become mechanical to stop recycling, retroactive like correction. Final thoughts. Your children told you the truth. Most people think corruption needs exposure. A whistleblower leak is kind of what if the system already proved it? Quietly, repeatedly, mathematically. You see, it doesn't create conflict if we reveals them. And once you can prove the system is broken, you stop asking permission to survive in it. Stop forcing it to justify itself. Good luck. Actually, no, you wouldn't need that luck, guys. You wouldn't need that glass. You wouldn't need that luck, guys. So that's the article I wrote and getting 20 minutes down. And basically, it's a real position stand. That article is basically on Devil2 forward slash at OB Nexus official. O for Oscar, B for Bravo, I for Indigo, N for November, E for Echo, X for X-ray, U for Miller, S for Sarah, the word official, O for Oscar, F for France, I for Indigo, C for Charlie, I for Indigo, A for Alpha, L for Lima. That's official, O for Oscar, F for France, I for Indigo, C for Charlie, I for India, A for Alpha, L for Lima. So that's what I'm saying. So this is the Epsilon collection letters. No. So this is a. Let me just try to. So that's about it. You know. So the seeking never problem is literally solving by trying to solve that never problem. But I'm gonna start doing the next video. So next video I should be doing more blueprints here. If I'm not doing the blueprints, I'm really messing up with the system I'm building anyway. So but I've got all the work I did on my YouTube channel. So youtube.com// at OB Nexus. I've got that work ready for me to go. Let me go and show you one more thing. So this is it here. So you're gonna have the formal paper here, formal paper here. Here, let me just publish this to publish to Devil 2, all these articles here. But the seeking never a problem. It's never gonna give me a problem. Because it's working litigation, which is what I'm good at. So how about so we got all these articles here, but I'm trying to find out. So this Rift, Rift the faithful translator. Mm, Rift. This is Rift is a flexible translator. Let me create a release for this. Um, so this is another project I'm working on. So this is not related to the current framework of system. I want this to be read around by the AI system. Welcome to our gym. Today we are off like so I really say yeah, I don't feel like I'm smart, fucking dumb. But we think connections communication. So we got what the time much time I've got left in the system. 22 minutes I have left. 24 I have 54 5 minutes sub. Collaboration with think connection. So we're gonna have Yeah, this is multi-connect collaboration. Multi-connect collaboration. So you go multi-connect system. This is a very important article to understand. That's something that connects a system. But let me search OBNX MK2 Muko Connect slash Muko Connect. Muko Connect. Yes, this is it. This is it. So byte state, the same thing here. Uh, so there's a file for me cooking it. So let me just find the code. So there's a custom system. So it's gonna be used to connect to the system. So this is the other file. So the other file is called Nuclear Calibration Connect. So Nuclear Calibration Sequence. So not series. So we think connection as calibration. Nuclear calibration structures rethinking calibration connection. So most systems think connection is simple. Open a socket. I don't know what socket is. Or TCP socket. Exchange data, close it, connect to universal TCP. I do know what socket is. The socket is UDP, CTP, TCP. Uh, those are sockets of Unigram data packets, uh, data protocol, uh, transfer communication, Unigram. What's a Unigram? I don't remember. So TCP is open a circuit with TCP token. This was the question, but this is not what I'm saying. So, this is basically what connects everything. So, I have to build a socket. So, the second thing is basically you have to build a socket of how the trial is going to work. So, this is the nuclear calibration sequence. Connection calibration. So, the nuclear calibration sequence is rethinking how you see orchestrate itself via the socket. So, the trial SDK and the motion all content via the protocol. And the product can do that, just make sure they connect to the right service. So they're going to use these pieces. So, you know, most systems think connection is simple. Open a socket, exchange data, close it. Congratulations, you requested TCP. Transmission communication protocol, or transfer communication. I don't know what it stands for, yeah, I do know what it stands for, but what if connection isn't about transport at all? It's about agreements. So this one is my favorite thing of the protocol. So basically sometimes you connect all the SDKs together, and that is what this is doing. This is connection system. So it's a calibration system. It's more of a calibration system than a connection system. But you are, because it's gonna be a lot of namespaces, and if it times out, so basically when we're timing out, it's communication timeout. Because basically a time connection time problem. That's about agreement. So we agree to connect. Not about transport at all. So this is my idea, just to do with the timeout thing of the protocol. But if my question times out, we can have different times. So any kind of educate, any kind of something linkage must be on show that they have to agree. It's consensual anyway. So what if connection is about agreement? The article introduces mutual calibration sequence, a model for organizations in SIGI framework to resume connection so many deeper. Not as we're linked, but to improve the byte stream everywhere. So, but do we interact in the same way, but not as we are linked. Do we interact with the same byte in the same way? So, the same byte means something. So, this is what I did happen to. A mutual collaboration system is an event of saves us. But what can I save it? Oh, oh, my watch is low. Shoot my pen. So this video is getting my battery is getting low. Uh, uh, Because you have so you get noise, you get no noise, you get entropy, no signal, you get signal. But much of low, which is very, very low right now, it's 28%, 27%. And you have no signal, entropy, no noise, structured but not meaningful. No signal, intentional absence, and signal for meaningful structures. So instead of assuming data is meaningful, we prove it first. So this is real world why NSIGII never fails. We will never fail if we get this right, guys. So it's like every byte window must form inside one state. No signal, no noise, no signal, no signals, no signal. But no, the tripartite stream. Stream equals transmitter, receiver, verifier. Three rows. Transmitter sends the bytes. Receiver classifies them. Verifier decodes them. Instructs them. What is a connection? A mutual connection is not a socket, it's just a handshake. A connection only exists if the verifier, receiver, and verifier can consistently classify the transmission of a stream with sufficient confidence. In other words, shared interpretation of data, not shared meaning, no connection. So this is a planar elimination. So, yes, this is obvious. So, axis one, entropy, uh, entropy, axis two, structure, axis three and four. You got four axes, so you get four dimensions. So, but they have meaning of signal, noise, no signal. So this is planar animation. Calibration performs planar animation that causes 2D's beginning to resolve. This is a 3D system. This is a 4D system because there are four dimensions. So you get axis one, which is entropy, axis two, which is structure or signal. But uh, so you're gonna have a dimension, but these are all dimensions on. So you can be either in a signal or no signal state depending on the plan you're on. And the elimination means if you calibrate to a signal, you get a pointer, like a vector that's lies in that domain that's calibrated to a system of signal or no signal, noise or no signal. So that's what doesn't never fails. Can't even be hacked. It can be hacked, but I don't know, play devil's advocate. Uh, it's a collection. Oh wait, what's my time now? 37. So the goal is to have we stop pretending that coming both noise and signal at the same time and force decision. Simple version is high to low noise, low to high signal, entropy structure, low to low, no noise, null or any, no signal. But there are basically this is different into four dimensions, which are four axes of dimensions between four axes is which can be their own dimension. So for example, you're gonna have entropy no signal to no noise to no signal, no signal to no noise. There are four combinations here, I believe. But let me do planning animation because I have to go planning stuff. So let me try to find planular, planular, planar geometry. Planular dimension course plane geometry. It's a bunch of ones that deals with study of flat two-dimensional structures, just lines, triangles, circles, and rectangles. The term flat exists on two-dimensional plane, which means they have only length and width, no depth. With no depth and height. This was referring to vector. Yeah, this is the easiest kind of geometry to get started with. Anyway, yeah. So yeah. So calibration works in a finite dimension. Um, you can use rotation, you can use to do it. You can have the NSIGII protocol verify this by rotating the axis on a finite dimension. So that's the NSIGII works anyway. It works on kind of rotation, polar rotation, polar rotation, it's usually verifier, so you can verify on the polar rotation of the SK is own SK, based on trying to point a model or trying to point it. What I'm gonna do now is stop this video. But I've done it. So you're gonna have the planes here. So I says, I'm right, but there's four here. Yeah, there are four, yeah. Or sometimes what's an idea. By states, entropy, classify, entropy. No, it's not approaching great, the sixth one. Yeah. So we have here an enumeration, import collection, import from input math, a class of byte states, noise equals zero, no noise equals one, signal equals two, no signal equals three. And you have an entropy of the data is a float, we return a float, and this float is if this byte is an entropy data, you have floating point position. But if you have classified, you have the data in a byte, we return a byte state. If not set, you call a byte, equals entropy, and entropy is literally uh you know a bit full code here. I can't wait to go to Nigeria. I want to go to Nigeria. Okay, so I can't see my screen anymore, but this is the full code here. So this is the byte state here. This character tuple C equals signal, no noise, signal and noise. This is the mathematical intuition I had. But there's a window of opportunity to connect and connect. So you can have a classifier. So classify bathroom as a window. Check for silence, compute noise and structured scrolls. Resolve 2D. And this code does work, does work. Let me just run it and show you connects to itself. This one is Bluetooth or not. You can use connect to system. So this is Miko Connect. Sublime. No, let me go to terminal. Let me go to terminal and run this code. So let me just run this code here. Yeah, so this is this is the other code here. Yeah, I'm running. So you're gonna have um let me just find animation. I love animation, guys. I can't wait to do it. Miko Connect. Mm, because so this I'm saying. So it gets connected on no noise, no signal. Noise, no noise, no noise, signal, no signal. They're connected. So this is the payload here. Let me just paste this here. Let me just paste this here. Let me just paste this code here and stop it. But I think it's basically dimensional, but you have one style. Yeah. Vector length 7. So you're gonna have rotating, you're gonna have polar correlation. Obviously, kind of 3 pointers. Thank you for watching this video, guys. Thank you for watching the video. Like, share, and subscribe. I appreciate it. To my TikTok and to my YouTube channel.